Hello, this is Bono. Today I'd like to talk about the theme of units and prefixes. So far we've looked at the basics of electricity like current and voltage and DC and AC. Today let's pause here once and firmly nail down all in one place how to read the units and prefixes we'll be using throughout the videos from here on. Units like volt and ampere and prefixes like kilo and milli will come up again and again. Pinning them down now makes everything after this much easier. By the time you finish this video, you will be able to say what the common electrical units, volt, ampere, ohm, and watt, each measure. You'll have a handle on which power of 10 the prefixes kilo, milli, and micro stand for, and you'll be able to do things like reading 3,300 ohms as 3.3 kilo ohms, all on your own. This is a spot where people who aren't fond of numbers or symbols especially tend to stumble. We won't use any difficult math, so please do watch all the way to the end. First, let's start with why units and prefixes matter so much. In a recipe, if you misread a teaspoon of salt as a tablespoon, the taste changes quite a bit, right? The same thing happens in the world of electricity, and the impact is even bigger. Say the current you are allowed to send through a part is 100 milliamperes. If you carelessly misread that as 100 amperes, you'd be trying to push, get this, 1,000 times the current, off by that much. And it's not the taste changing, it's at the level where the part breaks in an instant. A prefix expresses a difference that big with just a single letter. That's exactly why being able to read units and prefixes correctly is the most foundational part of working with circuits from here on. Put the other way, once you got this down, you won't have any scary moments in the calculations ahead. So you can move forward with confidence. Let's go through it one at a time. So first, let's get down the units we use a lot in electricity. Just as you measure length in centimeters and weight in grams, electricity too has a dedicated ruler for each quantity. There are 4 common ones. The first is the unit of voltage, volt. The symbol is written with an uppercase V. It's the ruler that measures the size of the force pushing electricity out. The second is the unit of current, ampere. The symbol is an uppercase A. It measures the amount of electricity flowing. The third is the unit of resistance, ohm. The symbol uses the Greek letter omega, written like this. And the fourth is the unit of power, watt. The symbol is an uppercase W. These 4, volt, ampere, ohm, and watt, are partners we'll use from here on. For today, it's enough if you can connect each unit's name and symbol with what it measures. The substance of what resistance is or what power is we'll cover slowly from video 9 onward, so we won't go deep here. Don't worry. Next is today's other lead, the prefix. A prefix is a symbol you attach in front of a unit to say which power of 10. You could call it a kind of nickname you put on the large or small digits. Instead of writing out 1,000 every time, it expresses it with a short symbol. The leading prefix on the making larger side is kilo. The symbol is a lowercase k, and it means 1,000 times. Picture it as going up 3 digits. Going even larger, there's mega, symbol an uppercase M, which is 1,000,000 times. On the opposite side, there's the making smaller side too. Milli has the symbol lowercase m, 1,000th. Going even smaller is micro, 1,000th of 1,000th, that is 1,000,000th. Its symbol uses the Greek letter mu. Beyond that, it continues with nano, written lowercase n, 1,000,000,000th, and pico, written lowercase p, 1,000,000,000,000th. Here's one important tip. These prefixes switch every 3 digits, that is by 1,000 times each step. Remember that shifting one step changes things by 1,000 times. And the thing beginners get wrong most is uppercase versus lowercase. First, kilo is lowercase k, and uppercase k becomes Kelvin, the unit of temperature, so it's a different thing. Next, a lowercase m is milli, 1,000th, but an uppercase m is mega, 1,000,000 times. Same m, but whether it's uppercase or lowercase makes a difference of, get this, 1,000,000,000 times. This really is easy to mix up, so let's just memorize them as a set. Small m is the small side, large M is the large side. Now that you understand prefixes, next let's get used to actual converting. Once you get the knack here, it becomes a whole lot easier. The way of thinking is the same as converting units on a ruler. Just like rephrasing 1 meter as 100 centimeters, we'll go back and forth with electrical units too. For example, take a resistance value of 3,300 ohms. This means 1,000 ohms taken 3.3 times, right? The name for bundling 1,000 ohms into one is kiloohm, so 3,300 ohms can be written as 3.3 kiloohms. The long number got nice and short. Now the reverse, a small number, 0.001 amperes. This is 1 ampere taken to 1,000th. 1,000 is milli, so this can be written as 1 milliampere. While we're at it, 1 ampere is 1,000 milliamperes, and 1 milliampere is a further 1,000 microamperes. We go back and forth 3 digits at a time. Until you get used to it, you'll be fine syncing with your hands. How many zeros do I move? How many times do I multiply or divide by 1,000? One last note on how to write it. A prefix is always written as a set with the unit joined together. For 3.3 kiloohms, you write the K of kilo and the omega of ohm one after the other. Also, if you write just the number and drop the unit, it won't get the point across to the other person. If someone just says 100, you can't tell whether it's 100 volts or 100 milliamperes, right? Remember, a number always comes with its unit and prefix as a set. Here's a field fact for you. Actually, the electrical units that came up earlier, volt, ampere, ohm, and watt, are all taken from the names of real scientists and engineers. Volt is from Volta of Italy, who invented the battery. Ampere is from Ampere of France, who studied current. Ohm is from Ohm of Germany, who found that famous law, and Watt is from Watt of Britain, known for the steam engine. Every time we read a unit, without realizing it, we're calling out the name of a great figure who shaped the history of electricity. And there's an interesting rule here. A unit that comes from a person's name has the rule that its symbol is written uppercase. So volt is written not with a lowercase v, but with an uppercase V. But be careful about one thing. This is a story about unit symbols. The prefixes from earlier, kilo being a lowercase k and mega being an uppercase m, were a separate rule. If you keep these two apart, the unit symbol is uppercase because it's a person's name, and the prefix case is fixed one by one. You'll avoid getting confused. Now a quick check to confirm your understanding. Again, 3 questions you'll trip on if you go by feel. Give them a little thought. Question 1. Writing 1,000 ohms correctly using a prefix, which of these is it? Number 1. 1 kiloohm with a lowercase k. Number 2. 1 kiloohm with an uppercase K. Number 3. 1 milliohm with a lowercase m. Question 2. Rewriting 3,300 ohms using a prefix. What do you get? Number 1. 3.3 kiloohms. Number 2. 33 kiloohms. Number 3. 0.33 kiloohms. Question 3. 10,000 milliohms and 1 kiloohm. Which is bigger? Number 1. The 10,000 milliohms. Number 2. The 1 kiloohm. Number 3. They're the same. Don't be fooled by the size of the number. Have you settled on each answer? Let's check them on the next page. Right, let's check the answers. The answer to question 1 is number 1. Lowercase k, 1 kiloohm. 1,000 times is kilo and its symbol is a lowercase k, and uppercase K is Kelvin. The unit of temperature, a different thing, and milli is 1,000th, so it went the other way. The one that matches on both the multiplier and the case is number 1. The answer to question 2 is number 1. 3.3 kiloohms. 3,300 ohms is 1,000 ohms taken 3.3 times. Since we bundle 1,000 ohms and call it kiloohm, it becomes 3.3 kiloohms. The answer to question 3 is number 2, 1 kiloohm. Milli is 1000, so 10,000 milliohms is only 10 ohms. 1 kiloohm, meanwhile, is 1000 ohms. In other words, 1 kiloohm is 100 times bigger. Going by the number alone, 10,000 looks bigger, but depending on whether the prefix is milli or kilo, the size flips completely. This was the most important point today. How many did you get? Go back and review the ones you missed. So this time we've explained units and prefixes. First though, electricity has dedicated rulers for measuring quantities, the units volt, ampere, ohm, and watt. And by putting a prefix like kilo or milli in front of that unit, we could nearly bundle up digits that are too large or too small. That's exactly why we could convert 3,300 ohms to 3.3 kiloohms, short and tidy. The thing to watch was uppercase versus lowercase. Kilo is a lowercase k, mega is an uppercase m. Especially milli's m and mega's m differ by a billion times, so this is the one spot we want to avoid mixing up. Looking at it this way, today's story connects along a single thread. Put a prefix on the unit's ruler to add a magnitude, and you can neatly read and write any size of electrical quantity. This conversion will be a tool you use again and again, so keep it in a corner of your mind. That's all for this time. Thanks for watching.